complexities in the geometries and junctions, in how they replicated the life around into a language of architecture. I mean, look at Gaudi, I think, was the last master craftsman who used this whole methodology of not drawing it by hand, but almost replicated the ideas through his models, through his chain models, onto creating wonders of architecture. What has happened today in the practice, the architecture has got so simplified in terms of certain principles, in certain way how the architects can draw it, that it has sort of washed out the complexities of day-to-day life. And needless to say, the construction techniques from a built-up of modules, whether it is wood, stone, or other crafts that were there, has got reduced to pouring in of concrete into molded boxes. So whatever molded box that you can annotate or notate is what you can construct. And that is where this sparked off a sort of a thinking that, what if we were to bring back the master craftsman, not in its original form the way they used to work, but what if there's a technology, what if the computers, what if the algorithmic thinking can be programmed to act like the master craftsman, to bring in those randomness, to bring in those iterations, which a human mind may take days and hours to think about, but it could be done in milliseconds using the computers. And this image is important to us. This is what we are based on. It shows to us that we like to get into the head of the computer rather than the other way around. So we like to guide the process. I mean, it's very simple to say that garbage in, garbage out, whatever you say in a computer. But in order to control that process of what you want the program to do, it is important to go through the cycle of intuitive thinking and combine it with the logical thinking. And that balance is something that we've been trying to achieve for the last few decades. We'll start with the first project that led to this thinking. One of the small residences that we were doing in Delhi in 2006. It was a standard builder residence with a column grid structure. And we wanted to somehow break that column grid visually by introducing walls that are off the grid that would just change the plane, a sort of a melting surfaces or melting points, or how you just drop wax into a certain space and it takes its own shape and takes its own form, is something that we wanted to experiment. And this experiment was more to understand how to construct something like this, how to draw something like this. We were so used to drawing grids, drawing straight lines, sections, elevations, that, to draw something like this in a standard orthographic format was quite challenging. And this is where, for the first time, we started using computers in terms of modeling and generating drawings directly from there. Drawings that could go for fabrication rather than drawings that would be constructed on site. The first wall that we constructed, which moves in all the axes, I mean, a standard method of working, we were inspired from a lot of projects which were happening. When I was in SEP, Hussain Doshi Gufa was going on, and there was ferrocement construction. But here, we wanted to do something which could be done faster and could be done as a much lightweight system rather than going with that extensive thing. We built an entire framework of plywood, a ribbed system, which is very common today. But in those days, the contractor and the client, everybody was surprised with this whole thing, and we were unsure of the results in terms of the precisions. The entire ribbed structure was built, services going through it, covered with a wire mesh, and sprayed on with a concrete, and then finished with epoxy paints. All the walls, which carried services, insulation, soundproofing, led way of thinking, a new way of looking into how buildings could be constructed or how objects could be constructed, rather than just putting a column grid system one on top of each other. How we could manufacture certain bits off the site, bring it, assemble it, and then partly finish it here. It's part of that idea of taking the prefabrication to a level where you could control the prefabrication. It is also not a cookie cutter design. It varies, it changes from every to another the surface that could just shift and move in all the three axes. Another experimental installation that we were doing in 2008, the brief from the client who were involved in doing, they work with stone, they do everything with stone in terms of the surfaces, finishes, products. And the idea here was to use stone in a way that it has not been used before, rather than just cladding it with standard stone, rather than just cutting it into certain sizes or the grids. Idea was to guide that whole process involved. Then this led us to create those walls in between, which were moving surfaces, a surface that would shift, change. We created stone surfaces with 1 mm thin kind of veneer, which was mounted on fiberglass, and it could be bent in both the axes. A sort of a skin that could wrap around within the internal surface. A product which was done with water jet granite cutting using the slicing technique, a sort of morphological experiment on form, or how a form could be created rather than carving it from one block of stone like a sculptor. We could use the slabs of stone, reduce the cost, reduce the effort in making it, and assemble it into a finished product. All these were experiments to just sort of get that whole idea of what form and how we could use these various ideas in creating space. As a full-fledged project in 2010, we were doing a resort in Manali. And here, the site was so beautiful that the first idea, the first design scheme that went to the client was a standard 8 cottages, column grid system. And we worked on it for almost 4 to 5 months, bringing about, standard RCC beam structure. And then we realized that, adding something like that to a site which is so beautiful, which is this, would not only disrupt the natural processes, the natural flows, but it's just another, a concrete box being placed in this beautiful setting. So we went back to nature. The first sketch that we drew was something that was inspired from how the anthill is, how nature works, how it grows from within the ground itself, how the surfaces of it could just be used to enhance or take over nature further, and they just sort of hide themselves into the ground rather than standing out like a concrete box. This architecture needed a different level of thinking. We were talking about Manali, which is difficult to reach. Work happens only 7 months in a year because of winters and snow and other factors. It's high up in the mountains. So we had to look at techniques of construction which involved prefabrication to a certain level. The roofs were designed almost with like these surfaces or these biomorphic pods to help the local moss over them so they could disappear into the hill. And these skylights, almost like eyes into the sky, getting the sunlight, getting ample amount of light in winters into each of the pods. The sun angles were calculated, and based on the sun angles and the constant light that we would get throughout the day is how these skylights or this wraparound ribbons were planned within the entire project. After the construction of concrete walls inside, the prefabricated, and here we did use ferrocement to cover all of it up. The amount of time it took to assemble steel, it took almost about 8 times to 10 times amount of time to do the ferrocement shell on top. We used the craftsmen to do the ferrocement, but it made us think that, we could continue doing this. We could continue making this steel structure and cover it up with a shell of concrete. But is there a process? Is there a way in which we could look at speeding up this process, making it more efficient, making it more accurate, and not leaving it? You're dependent on the fact that if the RCC or the ferrocement comes beyond the tolerance limit, would my skylight leak or not leak? We did not want to get into those kind of unknown areas. And it sort of led us to a next level of thinking. And while we won this competition in 2010 to do National Institute of Water Sports in Goa, it gave us a perfect opportunity to understand construction, architecture, structure, and this whole technique of drawing, or rather not drawing, and taking the models and the algorithms directly into a factory production, into fabrication, something we commonly call digital fabrication today, and to experiment at a very, very large scale. The idea of the project started off with a simple way of how a project could just become a link between the sea and the person who's using it. It's almost like a bridge. And the space should emulate this force of the waves, the force of the surfers into the wave, because it's a water sports, adventure water sports institute. And any and everybody who comes in there, we wanted a space that is moving, that inspires. The movement of the sunlight throughout the day should create enough shadows, enough sort of, that beautiful light inside to emulate the space which is inside the waves. The first set of models was these paper models that we did, just to understand the nature of twists and turns and folds of a wave. Series of experiments, series of these models. We photographed them, we digitized them, and the same digitized models became our basis for the first digital model that came out. And these became the building blocks or the spine for years of the fabrication that was to follow after this. The first model, the curves, the surfaces, the interior spaces, the scales, the structure, everything was getting defined while we were doing these models. This model went into extensive simulations of sunlight, of solar radiations, of wind, and to decide how and where we could place these skylights in order to get optimized sunlight in every space. Some space was an auditorium, some was a classroom, some were hostel rooms. So based on the amount of light or the lux levels required for each of the space, the skylights were formed, and the whole surface was divided into these panels that could be assembled off-site, made off-site, brought to the site, and could be just connected together to form this very large roof, almost about 45,000 square feet to 50,000 square feet, and a feature wall that was also a sound barrier and a wind barrier into this whole project. To control costs, to get accuracy, and we also had a restraint. It's a government project. It's a government project done using L1 contractors, where we could not use a crane to put it all together. So we had to break down the roof in small part, brought up using scaffolding, chain pulley system, and welded in place. The roof was designed to dissipate the pressure from the winds, which is coming from the sea. The sea is right next to it. It was designed as a sort of a pressure equalized system. And each and every module the drawing was generated through an algorithm. The fabrication drawings, there were close to 10,000 drawings for this. Each module, it's XYZ, which could be produced. It was not, a robotic construction for something like this would be so much easier. But here we were dealing with L1 contractor, standard welding, people doing it. So the drawings had to be absolutely precise with a tolerance of plus minus 5 mm. Welding and getting the Z-axis using the waste reinforcement from site. We just built a large bed of 5 meter by 5 meter in steel, and each and every module was constructed over it, getting the correct XYZs. Every module was part of that large jigsaw puzzle, which would get assembled into this roof, a complex roof that would carry everything. Rainwater analysis, doing the simulation, understanding the flow of water in Goa, the rains, and the sizes of the gutters that would follow was all part of this process. Rainwater analysis, not just for the roof, but also for the entire site, helping us design a landscape which would not only dissipate high waves coming in from the sea, but also would help in dissipating or creating this large water body in the center, which would be a natural rainwater collection pond. First sketch of how the roof detailing or how it would be, including insulations and multiple layers that were built into it, and the fabrication or putting together of it on site. This is a photograph that was clicked in July last year. The roofing panels, almost inspired from a simple origami procedure of taking a metal sheet, cutting and folding into form, was is almost like saying that, can you write down the steps of how to make an aeroplane by folding paper? That's what it's as simple as that. Writing these algorithmic steps. We had to guide the computer by writing these steps in order for it to then understand the lines that were there, which were as the center lines for the roof, and come up with its own, were generated literally in a matter of hours, the drawings for it, which went straight into the factory, and the cutting and folding happened through CNC machines. A simple process of the build-up of the roof with the skylights and the roof as on today, with each of the panels fitting it perfectly. These are simple metal panels, the galvanum sheets that you call the factory color-coded sheets, cheapest available in the market. Cut, folded in a factory, brought here, and just put in using a screw. The part of the roof waiting for it to get covered with panels. We also did sound simulation inside the classrooms so that the sound from one class does not travel to the other side. And it helped us understand how we could create these barriers or these clouds or these baffles in between that were suspended from the main ceiling without cutting the visual connect of the classroom. We were looking at a building system that builds from within, a structure that is responsive of the kind of architecture that we are building, rather than the other way around. We did not want to get restricted by the grid-based system in order to define us the beam sizes or the depths or the construction or the simple method where we could get responding to another system and working in harmony with each other. While there was still a lot of concrete that was used in that project, we started a small residence in 2018 in Delhi, which had a very complex brief, a very small plot, 160 square meter plot, with two sides as a neighboring property. Small frontage, just an 8-meter frontage with a 16-meter depth. We were supposed to design a down studio in the basement, a double height or a triple height down studio, and a residence on top. Sort of a complex program with control of sounds from one to another and has to work. So in a way, the functions were such that they were more dense on top and we needed a very open space at the lower level. And here, rather than going with the standard column grid system again, this was a system which almost like a tree structure, where the columns reduce when they come down and the column grid shift in their axis. So one column needn't be continuously going down. And it works as a system as a whole, rather than individual column and beam. So the truss on top, on the terrace, suspends the columns and the floors below. And the columns from below support a certain area. So it's an equilibrium system that works, almost like a tree system. Is built or fabricated off-site and brought in and assembled here on-site. A small video. 2009, we were also working on another project, which was the students' housing, or rather the NIFT campus that we're doing both in the residential part, and what it led to later. The site that's a 45-degree slope with almost 30 to 35 banyan and mango trees. We had to construct hostels out here, and we decided not to touch any tree or even a single branch of the tree. We mapped the entire site, and we divided
Manish, there is a lot of disturbance and not audible.
the the water flow, and without that would just sort of share it again, stop and share it. Was it
Yeah, your voice is breaking, so not able to hear you.
okay? Just give me
Yeah,
2 minutes. Is it fine?
yeah, now we can hear you.
Okay. Can you see the screen still?
Yes, we can see the screen.
Is my screen clear?
It's blurred somewhat.
Yeah, I'm sorry. There's power failure in Delhi, and it just had to happen today. And I'm just still running from my hotspot.
No issues, Manish.
So apologies for that. Yeah. Okay, coming back to the point that we use the contours to our advantage. We use the hill and the trees to our advantage. We took the hostel rooms, which is usually a standard size, as these cubes of 10 feet by 10 feet or 3 meter by 3 meter by 3 meter, and divided the entire site using these cubes. And those from SEPT who have studied under Professor Raje would remember this exercise of cubes and the light cubes in the second year of housing. I wanted to sort of recall that whole process and use that into an algorithm, into a thinking which could just sort of take it to the next level. So we use the same cubes, distributed it as and how they came over these contours, introduced the light cubes based on wherever we needed the lights, the sunlight coming in. There were a lot of trees, there was a lot of shade that was getting created. So combining those two, we were able to sort of understand which all cubes should be eliminated or the voids that need to be created in order to get uh, enough sunlight into every room. The circulations, platforms, and the overall plan sort of emerged from here. A plan that did not emerge in 2 dimension, but almost as a three-dimensional result of a simulation done. And this gave us a very clear understanding of what this hostel would be. G+1, G+2 hostel rooms sitting on top of each other, almost like these cubes that are distributed, giving enough sunlight and corridors in between that run at various levels. During the construction, again, at that time, we had to rely on RCC construction, zone 5, and it became a column grid system. There were a lot of restrictions in terms of the sizes, in terms of how we could put together, but in our best understanding, we were still able to come up with a kind of an architectural language which respected the trees, respected the nature, created the levels, or retained the natural water flow the way it was before this architecture came in. So it was pretty much in coherence with what was there on site, with these blocks just inserted in between. This is something that we completed almost 4 years ago, and by that time we were already experimenting with prefabrication. And I'm going to cover this in the next segment when I'll talk about the phase 3 of the hostels being built in NIFT and what we are doing next in future. But this is a sort of a built up from what I'm going to be talking about. An architecture which responds to nature through thinking, through the algorithmic thinking, looking at and mapping the site and respecting it and working in coherence with it. In 2014, we also did an installation where we were wanting to create this natural mount, a landscape mount, using a modular construction of waste shipping pallets. Just assemble them and create a sort of this green mound which people could climb, go under, a cavernous space inside and a mound on top. And the assembly was then further resolved in terms of these two cubes twisted, hollowed out, and a space that one could walk in or climb up. And it became like this Mobius space which you could go in and out and could be used for, as a landscape process, just for sitting, just for contemplating. So this is part of India Design 2014. It was a pavilion meant for people to come, rest, have a cup of coffee, hold conversations. And the construction of it, we did not make a single drawing. It was literally an Excel sheet that was given to people on site, just explaining the shift in the X and the Y axis from one shipping pallet to another shipping pallet. And the whole surface built up, or the form built up, was done using 4 sheets of Excel, given just showing X and Y shift from one box to another box. It made us understand how a structure could be created without a standard column grid, of how a structure could become as a wholesome structure by itself, using this equilibrium or the shifting forces of how you could support one to another. And we said, why not use this whole module or the modular construction at a large scale? If this palette could become a room or a space, and if we could distribute it, then we would be saved from what we did with that harrowing construction of column and beam in the NIF that we did. It was, of course, a modular design, but not constructed in a modular manner. It was constructed like a standard poured in concrete. So we thought, why not take this to the next level and present it in a way that we could build. So we did a comparison recently of a standard RCC building versus a modular construction where the entire module could be constructed in a factory, brought in, fixed using the crane, and the entire hostel could be put together. And the third, using the same experiment, but using shipping containers. A container which is a standard size, as you all know, of 8 feet by 20 feet or a 40 feet by 8 feet height. We did a rough cost comparison and the time comparison between an RCC frame and a factory-made prefab. While the cost was almost the same, the time was reduced by almost 1/4. And this is taking, optimistically saying that in 2 years, an RCC frame structure in a government setup would get over, which usually it doesn't. When we gave the presentation, we got a response saying, you are saying 2 years, it's going to take minimum 4 years, knowing how the construction happens in the hill using RCC. And here, irrespective of what the site and the constraint is, the time remains the same. So the language of a prefab block, a hostel room plan, which is a modular plan, we designed it in a way that it could be adapted in either of the manners. So a standard 8 feet block was taken so that it could be adapted to either a prefab or, in the worst case scenario, into an RCC. And that standard could be repeated into creating an entire hostel block as a first experiment into a government system of doing a prefab modular construction, where not just elements are constructed, but an entire room is constructed with interiors and exteriors in a factory, brought together and just fixed on the site. So that is something that we are looking at as a language of future. The module which we are doing, a similar hostel in Bangalore for fab hostels using shipping containers. Shipping containers are a ready-made module available in the market for years. And a container architecture is very common. It's not something new, but it was for us to understand how an assembly or how a space could be created using a modular construction. This brings me to another installation we did in 2017 for India Design, a sort of different experiment where we were supposed to design these series of installations throughout the plaza, the central plaza of India Design. We took an inspiration from the trees of Delhi, not the bright side of trees of Delhi, but the trees of Delhi that are being rampantly cut for construction. And when a tree is cut, it usually leaves a stump behind in the ground as a reminder that there was a tree here. We took that as an inspiration and we wanted to recreate these stumps at 1:1 scale for each tree, for each of the famous trees. The 7 trees of Delhi We picked it up, abstracted it, and we wanted to construct it using scrap steel to show that how an industrial process or how a process of construction rampantly cuts the trees and does not respect how what nature is. Gave us a perfect opportunity to experiment using digital fabrication. The first model being done in clay, experimenting with forms and intuitive thinking, developed into a form on the computer. The central ribs, which were cut on a CNC machine, just placed in place, not fixed together, were then held together by these series of metal strips, welded or woven, almost like a woven fabric on top. Something interesting came out of this experiment. Not just the method of construction, but it also helped us understand the mind of a craftsman. When you give a welder a machine to weld strips, each welder welds it with his own pattern. And that is the mind of a craftsman. That is the algorithmic thinking at a large scale, at a human scale, where your brains are almost in tune and each brain is used as a factor into the entire design process. So 7 different welding teams came up with all individual patterns of building it together. And that helped us understand that every process should not or cannot be guided on paper. Some processes, humans are part of this entire algorithmic thinking. Some processes should be just left. And each and every installation, after getting welded, after being woven, the skin itself became an integral part of the structure. A skin that was only 0.5 mm thick, 2.7 mm thick, became an integral part of the structure and it took the load. The internal ribs were in return supported by the skin and vice versa. Made us understand how skin could become architecture itself. And you don't need the standard column beam gridded system of structure of construction. This as an experiment, this as an understanding of skin which is breathable, which is structure, has now led us to use this system in our future projects. Visible from inside, largest structure, which was almost 9 meters high, held together just by the skin, minimal supports, and it withstood all kinds of wind forces. And there was a good windstorm that happened around that time. And we had a fear that the whole structure would fall off, but thankfully, and things were calculated beforehand, each structure survived. It let the wind pass through it, and it created these wonderful breathable spaces inside that one could use. In 2019, we were designing Goa Bazaar, another project in Goa, very similar to the Delhi Heart model, a crafts bazaar, where we said, why not combine the modular construction, use the shipping pallets, the shipping containers, not pallets, because a container is a perfect size for a shop. If you look at a Delhi Heart model, the size of the shop and the size of the container, they're almost similar. They're open, they don't need to be locked shops. We played around with Jenga for almost 3 to 4 days in the office, in coming up with various formations, various iterations that we could do. This is the intuitive thinking here before we could move to the computer, and came up with this entire grid of containers which support the containers on top, and a grid that keeps shifting. No column is continuous, and each container is in a different angle. There are enough cantilevers, there are enough spans. A 40 feet container is just spanned completely to create these large open spaces. Circulations that could be inserted in between, and an architecture that emerged, which was reminiscent of the Goan architecture of the streets of Fontanas or various places, in order to get that feel, that scales, but not using the same construction techniques as those buildings were built for. We also introduced these wind pods, as what we call it, the wind towers, which were designed to harness, the sea winds at 25-meter level. Again, a structure inspired from the installation that I just showed you, breathable skins, or a large pod, which is a good 25 to 30 meters high, would take in the sea winds at the highest levels and change the microclimate of the entire site. So we're using 250 upcycled shipping containers for the project. There's no RCC involved except for the foundation. These 30-meter high structures which would harness the sea winds, and a rainwater collection of 12 million liters of water in the center. as a natural pond. That's the key features of the project. We did detailed simulations for the wind. Knowing that tangent is where it sits, the wind directions, the dry bulb temperature, the relative humidity, and the wind speed was studied. We plugged in the real-time data from the Met department for every 3 hours and understood the wind pattern. We took the hottest day in the year for our simulation, and taking that hottest day, we wanted to bring down the temperatures and make a comfortable temperature without using any kind of mechanical means, just by harnessing those sea winds down. So by dehumidifying the winds which are cooler at a 25-meter level were brought down to the ground in order to bring down the temperature. Well, a complex model of what all it went through in terms of its simulation, taking the raw data from the site, introducing various layers in between. I'm not going to go into it as of right now, and a visualization result to understand wind vectors at various levels. So this is just a sliced plan to show visually. Of course, we have a 3D model of this to show the wind vectors, but just for our understanding on ground floor, first floor, second floor level, what the wind flows would be because of these pods available on site. And we were able to understand through our simulation that the comfortable temperature went up by almost 100%. The wind speed on the ground was increased to 220%. In order to get this cooling effect, this whole cross ventilation effect, and this to us was an amazing revelation. As you go up, the blue vectors, which represent higher wind speeds, keep increasing. And you can see very clearly how the wind is directed towards the water body, thereby making it cooler even further by the time it reaches the pods in the end, and it escapes out of the site. To show you in simple terms how the wind flow happens through these pods. All result of a simulation done, long-term process, understanding and putting it together. This brings me to the end of the entire talk. What is it all about, to put it all together? What is this whole design process? Is it only computers? Is it algorithmic thinking? Is it just logical? We've got these questions over and over again. Would the computers guide our design process? And I keep telling again and again that it's not, it has to be both. It has to be a balance of intuition and logic. It has to start off with storyboarding. It has to start off with a sketch that could be anything. It starts off with models of ideas. It needn't be a building. It needn't be a form. It is just an idea. And that could be represented in any manner. A sketch which is done, an intuitive mind, by the end of it, always takes the top. But how an intuitive mind could combine with the thinking of computers could help the results get much faster. And those results get vetted in time. So it's bringing back the entire thinking of the master craftsman, where he had a support of multiple craftsmen and the wisdom of years and centuries brought in, coded in, and the results that are vetted and work in real time. That's a sketch by Gary of Guggenheim, or John Utzon's sketch, the winning sketch for the Sydney Opera House. Sketches are important, and from there translating into a digital model and the iterative process to understand the geometries, to understand overall dimensions, the scale of X, Y, Z's into the entire thing. Of iterations, if not when, how, where, various possibilities, permutation combinations through series of switches are programmed in. Algorithmic thinking is as simple as saying that, should a window be 600, 900, 800, or should this entire dimension be divided into 1/3, 2/3, and this proportion? Then every window works with that proportioning system. So you put in that, and we've done that for Goa. We've not given dimensions of windows, but we've given the proportioning system. So on site, it is divided as per the site, the things available. That is the difference in algorithmic thinking and a standard way of looking at. Iterations for the Goa projects, multiple iterations that can be produced using an algorithm. Those iterations that can be vetted. Resolutions, which is analyzing those iterations and optimization of geometry. Whether it is the daylight analysis, this is for a house that we are doing in Delhi, where the sunlight analysis was done for an entire year And we got almost 40,000 iterations of the floor plate plans to get the best sunlight in the basement, out of which we chose one model and built up design on. Solar radiation analysis, going to, so there are multiple ways of looking at a pedestrian analysis, something that we did for a project that we were doing in Kashmir, in Srinagar, an art and craft center, which was an adaptive reuse of these old silk factories. And we mapped the human movement of where the possibilities of people taking various routes at various times during festivals, weekdays, normal days, various kinds of people. What is the probable paths that they would take to reach these buildings, and how those probable paths could be then used, that data that can be used to assign functions to each of these buildings. So if I have to place a cafeteria, what is the right place of placing the cafeteria? Which is the right place of placing the office or the exhibition space, was all a result and a part of this analysis done by various simulations of these avatars walking through the site. Water flow analysis, which we use for every project now. What is the natural water flow? What is the volume of water that will flow to various points of site, and how that water could be controlled, channelized, or not disturbed, and the architecture could be based on top of that. Structural analysis and optimization, understanding the shear forces, understanding deformations, understanding the bending moments, and then the fabrication analysis and optimization, how that entire structure could be optimized and fabricated, saving the material and the costs, the human cost and the material cost. How it gets translated into drawings, how that fabrication drawing could be generated. So this is a drawing of one of the modules where each and every tube, the dimension, the angle, how it's cut, how it's put together with its axis has been shown clearly. And this is not drawn by hand. All of it has been generated from the algorithm itself. The cutting and folding of each and every panel on the roof. 5,000 panels, but just one page showing you the various drawings that were generated, the open patterns that the machine could understand, cut and fold into individual panels. Or the ribs, the file to factory production, and the assembly of that module, they were welding it together. So it's a closed cycle of inspiration, resolution, manifestation, and translation, and it continues. It's a closed loop of the intuitive and the logical mind. And each and every time within our office, each one bets the other person. So at times when we feel that we need that sort of intuitive thinking into it, we keep changing our program or the algorithm and keep fine-tuning it every time. That's it. Thank you.
Thank you, Manish.
I'm sorry for the disturbance, but I hope you got most of it.
But it was wonderful. I think, honestly, I've enjoyed like what you had written down in the process, the description, and we could see the evolution of the practice. Few threads that I could identify, and maybe there are actually many threads. I mean, that cube exercise of the Raje that you mentioned, and you started on that contour side for the hostel. Now that is a theme, okay, and it is developed over a course of many projects. So then comes an installation with, and then the Goa project, okay, is also, it is taken further. The second is those the shell that you started developing. So in the installations that you did in the Delhi, you could experiment something at that scale. And now when you go to that Goa project, so in many ways, I see that your Goa project is kind of becoming a culmination of
Yes.
many processes that you have been
Yes.
exploring over the period of time, and it's
Yes.
really fantastic to see. So I would actually like to invite the guests, Arpi, Adnan, anyone who wants to jump in with the questions. You're most welcome.
Manam should start.
Yeah, Arpi, you want to go first?
Sure, I can. Wonderful presentation. Thank you, Manish. It was inspiring for me, and I hope for the viewers as well. So I think one of the things that I face when I teach, and I would like to ask you the same, is what are the different types of softwares of the plugins that you are using, right? And how do you, because there are multiple of them available, say for wind or sunlight. You also analyzed pedestrian flow for the last one. Then you did sound analysis. So what are the different types of softwares that you use? And B, when you run so many iterations, how do you eventually find, select one of your final outcomes that, this is the one, or is there a process, and what type of process do you employ for selecting, one optimized solution?
So, okay, to answer your question, Arpi, and this question has been asked multiple times, even on our social media, what softwares do we use? If I was to talk about the number of softwares or the apps that we use, this would take probably an entire day. It's a directory of things, and it is not easy to just say one or two because there are so many plugins, so many things that we write on our own, so many codes that we write ourselves, that it's not an easy answer to just give you that this software we use. We don't use the standard softwares available in the market. We use the platforms available, the standard platforms. But I think it would take an entire days of discussion, and it's not worth giving you a list of softwares that we use. It's not important. It's not the list of softwares. It's the thinking that is important. It is what is important is what to apply where. And that's where the intuitive process comes in. If, for example, we're thinking of dividing the entire roof, and there was this entire discussion that happened in the office that such a large roof, what is the size of the module it should be divided into? Should it be a module which is 4 feet, 6 feet, 8 feet? What is the optimized size? Of course, there's a range because each module is a different size. So there has to be a range decided for it, that maximum to minimum size. What is minimum and what is maximum? That process goes on simultaneously in the office while somebody is coding and putting a program for it. So we keep fine-tuning both with each other, and that is extremely important. So when you say which iteration to choose, the intuitive mind is working simultaneously with logical mind. The computer gives us iteration. We go back to the drawing board, go back to sketching, modeling, looking at the proportioning system. We use a series of softwares to visualize the space. Of course, there's a common software available as Enscape. You can just visualize any space. You can walk through it. We use various other visualization softwares to see what is happening. So in our office, at any given point in time, a sketch, an algorithmic model, a real model, a rendered model, and a walkthrough are all happening simultaneously. So I could walk to any table and see this process all together. In fact, now we've gone to a level where we've included even VR into this, where we included the client, the house that we're doing in Delhi. We created a VR experience for the client. While he was wearing his headset, I was wearing my headset. We were going through the space together, through the entire model, and we were designing with the client. So he would say that, the vanity level in my toilet seems a little lower to my height. Can you increase it? I want to feel it. And there, sitting in my office, I would change in the model. And on his VR set, he would be able to feel and experience that whole thing and say, now it seems right. A 10 centimeter increase in height seems right. This scale seems right. This proportion, okay. We've gone to a level where we are simulating the actual space down to its detail, its light, its materials, its textures, and giving an experience to the client, understanding where he can get. And all this is happening, the back end of it is changing things in split seconds. And I'm not kidding when I say split seconds. If the client has to say that, I don't feel the light coming in here, I have a backup platform that is telling me that winter sun on 25th of December will give me at 12:05 this kind of sunlight on this table. I can predict that to the client, say, put your table here and you're going to get sunlight on your Christmas lunch. And that is the process we are following to that accuracy. So yes, there are a lot of backends to it, but the front end of it seems simple, but there are just too many processes for me to talk about it. I hope I answered.
Almost, fair enough.
Yeah. Happy
we can switch. I guess Adnan can ask.
Yeah, Adnan, you want to jump in? You're mute, I guess, Adnan. You still...
Yeah, now I'm audible, right? Okay. So you are talking about transferring logics, right? So essentially when there were master craftsmen, they had a certain kind of logic with which they were working. Now what we as an architect are doing in such a practice is then decoding their logic, transfer it transferring it into form of an algorithm, or let's say you call it a genetic algorithm, generative algorithm, AI, whatever, but basically a logic in form of a script.
Yes.
When we do such a process, I feel there is a great opportunity, especially in a market like India, where a
Yes.
lot of buildings are not designed by architects. And if we are able to translate that logic in some kind of a script, and then if we
Yes.
are able to transfer that to masses,
Yes.
it can do a lot of good, right?
Yes.
What are your thoughts on that? Are you working on
We,
it?
it's a wonderful question, Adnan, and we are already working on something like this. We are we are actually coding Vastu. We are actually coding the bylaws, so
Mm-hmm.
that a client before he comes to us could use a simple app in terms of understanding what his building massing could be. You know what his house massing could be once he puts both these algorithms together. He employs the algorithmic thing, the Vastu thing, or the bylaw of the local area, and he could come up with a basic form model for him to understand. This is where it would come to. Of course, it's not intuitive, but it's almost saying that since you're working on AI, we could actually feed in all this data and understand, and maybe in the future of tomorrow, we could get something that you have a client, you have a site, and he, without involving an architect, can understand what his house would sort of look like. It's not the visual sense of it, but the soul of the house. What all the courtyard, what are the iterations that one could get. We are already working towards that, and that I think is the future of architecture. And when you say coding the craftsman, we're not just coding the craftsman. We're not decoding just the craftsman. We're decoding life in general. We're
Yeah.
decoding how people live, how people move, how people react to certain spaces. It's decoding the human mind and translating that into design, of how design can respond to the human mind, rather than one architect who comes along, says that I am the master architect, this is the grid, and you live into this space, you live in this cube, and there is a wonderful light, and there is this beautiful brick thing, and there's exposed concrete, and you're supposed to appreciate that. There is a huge gap, and we all know this. There's a huge gap between what people view architecture and how architects view architecture. And this algorithmic thinking is to bridge that gap, to bring it as close. Of course, to say you cannot have, there is a certain ability of an architect to look at aesthetics, to understand a deeper processes that go behind the multiple layers of a construction or lifetime of a house or building that you're doing, which a non-architect does not or cannot understand. So this is using the skill of an architect or the entire learning in the right direction. It's to say that I am not going to be sitting on top of my high chair in my office and direct this process and you must live into this space, but it's almost like weaving and understand the mind of the client and the people who are going to be using it, so that when it comes out, it just mirrors the brain of the people who are using that space. That's where algorithmic thinking comes in, and that is what decoding to us means.
You know,
Crafting is just one process out of that. Yeah. Yeah.
yeah, please, sorry to interrupt. When I look at, let's say, and I see that it is inherent. I mean, it has always been. For example, when I look at the vernacular architecture, and this is an example that many times I give to my students also, that if I look the pole houses of Ahmedabad, you
Yes.
can
Yes.
literally extract a system out of it. You can
Absolutely.
extract the algorithms out of it. You can
Absolutely.
take it to any software and create as many iterations out of that thing. So
Absolutely.
it was happening subconsciously. So if I look at that knowledge bank which was there, which was built
Yes.
over a period of time,
Yes.
and it found its manifestation in the built form. And so if I look at the old city house, so I can extract a few diagrams out of it that this is what the type
Absolutely.
is. But then you
Yep.
find so many iterations of that one type in that city. No two houses can be. You will never find, very rarely, that the two houses are the same. There is
Yep. 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 Yep.
n number of iterations are there in the old city. So, but I think now, and Adnan's question was really, really, triggered me, as is that when we look at many of the parametric explorations, this is where the real opportunity is to get it into the masses and make the most out of it and take it to the mainstream, maybe perhaps.
Yeah. So architecture was always forte of the masters and the craftsmen. There was a relationship between people who built and the people who they built for. It was a very close-knit network, always. And when you talk about vernacular architecture, it was just that. It was this close relationship between the people who were using that space and the people who were building that space. They were not two separate entities. You did not walk into a glass boxed office of an architect to say, this is my brief, you design, and this you do. No, the craftsman was there. They were building it together. And that wisdom, that logic is something that brought in so many iterations based on the functionality and the cultural usage of that space. And mind you, I mean, vernacular architecture has always been an Achilles heel for the modernist architect. It's something that a modernist has not been able to decode completely and has sort of surpassed that entire thing in terms of saying that, oh, that is just too vernacular. And there have been movements, of course, with due respect to all the previous architects who worked on this, there is this oversimplification of the vernacular in the modernist architecture. And that oversimplification has not only killed the vernacular, but has also killed the craft of building architecture. Everything has got reduced to just pouring in concrete. And this fascination to expose concrete or this fascination to pour in concrete has sort of changed the entire thinking process. When you built vernacular, you built with elements. If it is a wooden construction or a stone construction, every joint, every element was brought in like a prefab element.
Absolutely.
And it responded to a logical thinking. When you're pouring in concrete, you are just responding to what a single mind is doing. Whereas a vernacular thinking is millions of minds put together, the wisdom of all those minds. And that's to say, I mean, it's Adnan would understand when I'm talking about this, an AI understands million data points together compared to a mind of a single architect. And that's a huge difference. And that is a shift that's already happening across the world. I mean, sooner or later, the architect needs to step up and understand that this thinking is something that we need to adapt to in order to survive, in order to create. Because that decoding and coming back, the mistake that we did 100 years ago, and I call it a mistake again and again, much to the the displeasure of a lot of my contemporaries. It's a mistake that we did 100 years ago in coming up with a system that was an oversimplified system of architecture. So yeah, I think we are reversing that process now.
The way I see the process is that as a human, we are only able to, let's say, think about 4 or 5 parameters, or let's say maximum, if an architect has a lot of experience, 10 parameters at a time for a building. Well, once you start using algorithms, you can have n number of parameters, and the building will be optimized on that n number of parameters. So the potential is huge in that direction.
Exactly. I mean, when we did that, just a simple factor of getting, so the brief from the client was, we want to plant a tree in the basement, and at that spot, we need to get our house plan in such a way that that spot gets the sunlight for almost 2 to 3 hours every day. How do you decode something like that? A computer program written was able to produce 40,000 iterations in 12 hours. And we had to stop after 12 hours because it would continue giving iterations. And out of those 40,000, it gave us best options, and it kept by itself reducing down to the best option. That combined with a functional plan gives you what you're looking for. Tell me how an architect's mind can think something like this. I mean, you'll draw light, you'll draw shadow, but would it be as accurate? Can you pinpoint and say that exactly at that point on this day, at this time, the sunlight would fall? Nobody can predict that.
Yeah.
A computer can.
Absolutely. Yeah, please, Adnan, please go ahead.
This might be a stupid question, but again, so for people like me who are just starting out, we have an assumption that government projects mostly happen with bidding process, and they don't understand how the nuances of design work, especially the parametric design or this data-driven design and all of that. Can you share more insights on how negotiations happen in such projects, like when?
You are asking me my trade secret. You're asking me my trade secret, is it?
Sort of.
Sort of.
Yeah, we'll catch up over coffee for that separately. But anyways, I mean, I think every human mind works on the simple principle of what is delivery and efficiency. Mm-hmm. It is not about government or private project. It's not about this. As long as the architect keeps thinking what I do is the best, and that in our language we call the architect's ego, that we do this and people should accept this. I think in order to push anything, any design, any idea, what is important is to understand what the other person is looking for. And most of the times, in every project, everybody is looking for efficiency, both in time and cost and the usage of that project. As long as you identified that, you have controlled the cost. I mean, the Goa project, even if you were to imagine the overall cost of this project, take a wild guess, as an architect for a digital fabrication of that scale, which is 1.5 lakh square feet of area, we had these sort of interviews or talks with people when we say guess the cost. Everybody guessed almost 2.5 to 3 times the cost of what it actually is, and it is a government tender. I cannot increase the cost. I have to reverse calculate it. So every process, every engineering or the craftsmanship of everything has been done to stay within that cost, and you cannot increase costs. It is literally, we were able to control costs as long as you've done that and your usage is worked out. I don't think whether it's government or private would have a reservation with what you're doing. Most of the times, parametric thinking just becomes a form building exercise. It becomes a facade exercise. It becomes, I want to tell all you youngsters, move beyond the lampshades and the flower vases and think about how you can make an engineering system more efficient using the parametric thinking. It is not form building. Invariably, the people who apply to us or people who talk to us, the youngsters, say that you can do a form building using parametric. Is not form building. Parametric is a thinking. It's the way to think of how to make processes more efficient, how to bring down costs, how to make the ease of construction, all of that. To make the process easier, isn't that what a role of an architect is? I mean, why has a client hired you? Because he can't construct. And he expects that you are an expert who will give him cost efficiency, time efficiency, and usage efficiency. If you can't provide that, then what's the point of being an architect? You use the algorithmic thinking just to deliver that. As long as you've delivered that, the form, look doesn't matter. That's your prerogative. That's as simple as that.
Yeah. And there is also an environmental angle to this. I mean, particularly, I was looking at your Goa project that you showed and the wind catcher. So you can really now, optimize the resources, and that is also something which comes as a part of, the fact that you have a lot of plugins, a lot of already available, which help you analyze your decisions in a very quickly, and that through that you can really achieve one. For example, in Goa, of course, the wind cross ventilation is perhaps going to be one of the most important thing in order to achieve the
Absolutely.
triple comfort. So now
Absolutely.
I sit and say that, okay, look, these are the iterations, and this is the best possible way in which I can achieve and minimize on the air conditioning cost. So there is definitely an environmental angle to and the sustainability angle, which is also somewhere you mentioned.
So there's no air conditioning in that entire project. It's without air conditioning in today's time, because we are able to create this large air conditioner at a natural level that can harness the wind.
Absolutely. So, Adnan, if you have
No,
questions,
and
so
I just have one question, I guess. What is your take on the usage of different types of materials? In world right now, we are maybe stuck to, say, we've moved a little bit from bricks and we are stuck to concrete and steel and glass. So where do we go forward, or do you think this is it and we'll be stuck here forever?
I don't think material as material. Don't get stuck to a material. We in our firm, we always experiment with newer materials. We use a lot of upcycled materials.
Right.
So most of the wood that we use comes from the shipping pallets. It's pine wood, bottom line. And once treated well, we work on a lot of systems of treating a certain material that is a waste material in order to revive it again and give it a new life. So a silicone dipped wood makes it waterproof for the rest of its life. The water just slides off it. So we have developed a lot of such materials, and with research with the industry, where recently we developed an entire board with Tetra packs, waste Tetra packs. So, it's just compressed Tetra packs and turned into a high density board, which can be used for internal partitions. So we do a lot of such things. We don't get stuck to, let's say, only a brick building or an exposed concrete building can give you that thing. We're open to that. We explore the unimaginable. We explore that what if it was this and what it would look like. So the possibilities are open. We think like a child. Why should it be a list of materials that one should keep using all the time in order to achieve? It's not the look, again, it's the soul of the building. The body can keep changing, the skin can keep changing, but the soul has to be there. So in order to do that, in a lot of times we use the cheapest materials available in the market. Like the Goa roof uses a color-coated gadolinium sheet. the initial quotes that came in from CalZip, from VMZing, from all those companies that do like doubly curved roofs or those forms, we were able to put a buy a sheet which is literally 70 rupees per square foot in the market, and was done in 150 compared to a 650 or 1,000 rupees a square foot for a metal roofing in the industry. So the idea is to find solutions or cost-effective solutions and wait for a newer result. For all you know, a look is something that you have not imagined. Sometimes we are so hung up on that pretty postcard image of what the architecture should look like that we forget that there is a newer possibility that one could look at. I love exposed concrete buildings, and I've done those in the past. But I would not restrict myself to that. I would not say that only a brick or a concrete building is a beautiful building. I mean, of course, that's the narrative that is everybody is comfortable with in the industry. Most of the magazines, most of the media, you see printed images which are of a similar nature. But that is something that we are in our comfort zone. We don't want to come out of that comfort zone. We don't want to look at a building or something that uses something new. We want to avoid it because it does not fit into our image of what is aesthetic. And what is aesthetic? Bottom line. Aesthetic is something that we define over the ages. There is no definition to it. Yeah.
Manish, we've been listening to a lot of, this is the sixth interview, and one thing that has constantly been coming up is that when I talk about, let's say, parametricism, or either whether I call it computational design or algorithmic design, but in a kind of paradigm shift they are bringing into the field of architecture and design. Okay, and we have seen in your work an expression of that thing. Uh, how what are the challenges? Number one, that in terms of the context of the India, and how do you think the industry and academia are geared towards that paradigm shift?
I I've also been teaching for a while, and every institute, or rather wherever I've taught and wherever we get a lot of students to work with us, the academia is not geared at all. We are still repeating the same old models. It's like saying the broken record is being replayed and played over and over again in every institute. And I say this openly for every institute in this country. And I think both RP and Adnan would agree with me because both of them have studied outside and understood, what is the difference between the academics here versus what happens across the world. We are repeating the broken modernist record for years now. And the change needs to happen there. The change needs to start happening at a thinking, at a base level. An architect needs to adapt to technology. It's as simple as using, I mean, people say that when the smartphones came in, everybody was of this opinion that people may not get used to it. How would the old people use it, or how the older generation would use it? Today, my dad, who's 78, 79, uses a smartphone very comfortably. My mom places orders on e-commerce sites like anything. So if that generation can get used to, there is a way how a smartphone industry has infiltrated into your lives. And somehow technology has not infiltrated into architecture. Architecture, you would know if you take the World Survey, is one of the only industries which is way behind in using technology than any other industry in the world. Any other industry. We are so averse to technology, and then we've got these torchbearers who say that technology will kill architecture. So that thinking is somewhat needs to kind of, I don't know. I think it's a younger generation that can change that. I think it's guys like Adnan or RP who can bring about that change and stand to their ground saying that as long as you know that parametric is not form building only, you can fight it out. You can change that thinking and say that technology does not kill design. It actually vets your design in a much better manner. So I don't believe in these cliches or these stereotypes that a certain way of thinking is the only way of thinking. I think we need to move past that.
Yeah, I think that's great, and I would like to conclude on that positive note. Thank you so much, Manish, for
Of
giving.
course, after this interview, I don't think I'm getting invited to any of the architectural parties with my contemporaries. I think all of them would block me after this. So, but That's what it is. That's the truth, ugly
Manish,
truth
we
of
have
it.
known you. You've been senior to us, and we've seen you, and it was so nice to see you after so long. And you are still continuing with that spirit with which you used to
Oh,
do your
it is the
designs.
same thing in SEP. It was that in SEP also. Did you see the same thing? Because
Yes,
I
I
can't.
sort of, that newer ways, you question, to don't buy anything just for the sake of its face value. I mean, you go after that, you question that, and that is something that we have again seen today. Personally, because I've seen a lot of your
Thank
design
you. Yeah,
studios.
yeah,
We've seen those things getting continued in your
yeah,
work. It was a pleasure
yeah, yeah.
to see your work, and thank you for joining with us. I'm
Thank you.
also
My pleasure.
thankful. I'm also thankful to Arpi. Thank you so much, Arpi. Thank you so much, Adnan.
My pleasure.
It's wonderful to have both of you.
Thank
And
you. Thank you, all of you.
uh, I would like to conclude here with one simple note that this was our sixth interview. We have the last interview, which is going to be our seventh interview next Saturday morning, 11 a.m., with architect Monish Siripurapu from Ant Studio, again, I think from Delhi. So I hope that to see you all of you back again next Saturday for one more fantastic presentation and one more fantastic discussion followed by the presentation. Until then, thank you so much for joining with us, and see you next Saturday. Bye.
Thank you.